Hello everyone, in this video we're gonna learn about what is melting a data frame. We will be doing that using the module Pandas, and we also use the billboard data as an example that melting a data can be applied to. So let's get to it. So the first thing we will do, as always, import the module and also read the data. And this data is rather large. I mean, the structure of it has so many columns. So to make this a little bit more manageable to understand the concept of melting, I've made a small portion of the data. I'm keeping only the 6 week of all of those 76 weeks to sort of like make it more manageable for the purpose of learning melting. So all I'm doing here, I'm just specifying a number of columns that I want this other data frame, which I'm calling it small data frame, to have. So the name of the other columns are just going to be removed. So once I do this, now I have a much more manageable data frame that only has 6 weeks of all of those 76 weeks. And I've also changed their naming to make it a little bit more presentable. So let me show you what melting a data frame is using this picture. So the data frames, or the data frame that has multiple value columns, it's in a format that we are actually more used to seeing. And it's sort of make more sense for us because we're used to spreadsheets and also tables on Microsoft Word document that for the purpose of keeping the data in the smallest possible space, and also being able to like look at it for a person, for a human, that way of structuring data was useful. So if you look at our data, the week 1 all the way to week 6 are sort of like these value columns that are about all of these, all about these basically tracks. Those values are the most important part of this data. But these other columns are identifying columns, or they are about, they're describing what those data objects are. So those are the identifying columns, and then we have value columns. So here there are our value columns. So basically, when you melt a data, you stack the value columns on top of each other instead of having them next to one another. And when you do that, now you have to also repeat your identifying columns for each time you have a one of the times that you're like representing one of the value columns. As you remember, our air pollution data was sort of like in this format that we found it a little bit surprising that we were used to seeing the data this format, but it wasn't this format. It was already melted. So as it happens, sometimes we need to melt a data frame to this new way of looking at the data, or like keeping the data, or we have to pivot it back to the data that we are more used to seeing. It depends on the purpose of the analysis. Both of these functions are very useful. So let's look at the example. For doing the melting, you have to call a function and specify 4 inputs basically here. So you specify your identifying columns. Basically, what are your identifying columns? Here, these are IDC1, IDC2, IDC3, but here, these are artist, track, time, and date enter. So these are the identifying columns. And then after that, you specify your value columns. What are those value columns? So for this example, these are VC1, VC2, and VC3. But for here, this example, there are W1, W2, all the way to W6. So those will be the value columns. And then you have to specify the value column identifier, or basically what you want those value columns, or where you want those value columns to be recorded. So this is a value column identifier that, you know, it's a column that is added to the data frame. So instead of having a column to specify which value you're looking at, this column now does that. So what do you want to name that value column identifier? In this example, you know, because it makes sense, I'm calling it week. And then lastly, what is the name of the column that you want to show all of the values? And you know, normally you call them value as it was in the air quality data, but here what they are really, they are rank. So that's why I'm calling it rank. So once I specify my identifying columns, my value columns, the name of the column that I want the identifying value columns to be presented, and also the name of the column that I want the values to be presented at, now I would, you know, in a very quick turnaround, I will have my data completely restructured, and it's a very powerful function. If you did not have this, you would have to end up doing a lot of programming, but this function just does that for you pretty quickly. So I mean, like, we are seeing that W1, W, you know, all of them are here, but like we are not like looking at all of the possible, you know, this actually working, because you know, we are not seeing from W1, W2 all the way to W6. So let's take a look at just one of the tracks and see if that is working for that one track. One of the way you can do this would have been to do a Boolean mask and say, I want the name of the tag to be Maria Maria, and that would have done the trick for you. You would have seen week 1 all the way to week 6 that, you know, they're saved in that way, or they're like presented in the data in that way. But there's another way that I'm also including in this video, is just saying query. In query, you basically pass a text that Pandas can recognize and decipher and understand what you mean. So you have to follow the guidelines, or follow the way the Pandas will read it, but the Pandas is very forgiving here, and most of the time if you give it a try, you're probably like doing it the right way. So track is equal to Maria Maria, and you can see I have to use double quotation here because, you know, it's within the single quotation. So once I do this, I get the same result. But I can see that now W1, W2, W3 all the way, they are working the way I was, you know, the melt has worked the way I wanted it to work. Let's look at another BM, like Boolean mask versus query. So I could query date entered greater than this date, or I could do a Boolean mask, which for both case would work the same. So querying or Boolean masking are going to work for you just the same in this example. There are things about this melted data that I would like to change. One of them is that now that I have a column, you know, to represent what week, sort of like the W is extra, and also if, you know, it's a week, like week 1, week 2, all of them are going to be numbers, why not collect them or like record them as integer? So in that way, I might be able to do other functions or other codes that uses that week column as a number, and that will allow me to do that. So I'm applying a lambda function to the week series to sort of like make that into an integer number. So I'm just saying I want it to be integer, and I want to have whatever character that sits in the second, or like index 1, which is seconds, index 0, index 1, which is the second. So it's like W1, 2, 3 all the way. I want to like change that into integer, and I apply that function to the week series, and now these are week, and they are also integer. I also look at this date enter, and I want to see what type of data it is, and it is string. And a lot of times, if you want to do a lot of other calculations that are relevant to date, add a couple of dates or subtract a couple of months that are based on date time format, you cannot do that when they are saved as a string. So Pandas has this powerful data object as date time that you can convert this into that one, and then do a lot of other calculations. So you use the function, we use a function to date time, and that column is basically converted to the date time. Once I do this, now all of these date enter, we don't see any difference, but their their data type is completely different. It's like timestamp now. It's date time. So now I can change this date enter into a real date based on these number of week, right? So if it's week 1, this date enter is the same week as that one. But once it's week 2 or week 6, this date enter is not relevant to this value. But I can use my understanding of the society calendar to calculate this new date and have a date updated there. So basically that's what I've done here. I'm saying pd.time delta, I want to add 7 days based on what number of weeks that is there. So if it's week 2, I want to add 1 week. If it's week 2, I want to add 1 week. If it's week 3, I want to add 2 weeks. Or so on and so forth. And once I do this, now I have added a date that is relevant to this reading of the ranking. And now I can go ahead and drop this column and have a melted data frame without that one, that the date also correspond to that ranking that is presented there. So on challenge 1, or like the only challenge in this video, I want you all to now, so we saw how melting this data was done based on a small data frame. But now I want you to do the same thing on the larger data frame. And there are some challenges along the way, and try to figure them out. So try this challenge for yourself, see where you get, and then come back, start watching this video. This challenge is pretty challenging. So I will sort of like, after you come back, after stopping and giving it a try, I go over some steps, and then again give you a chance to continue on your own while we move towards finishing this challenge together. So first we reread the data, and we drop some of the columns that we don't want to work with. And once you reread the data, the very first challenge that you will have to face is you will have to sort of like type out all of the from W1 all the way to W76 to reformat your data frame. So do you see? So if I, let this be shown, they're like XS1 week, these columns in. As you remember, when we were using melt function, we were using these columns names. And these are like sort of like cumbersome column names. So we want to like change the column names first. And to do that, we need to come up with alternatives. And one of the challenges is here that you would have to end up to type from W1 all the way to W76, but you don't have to because it's a programming language. You could do an inline for loop the way I have done here, W1, W2 all the way to W76, or you could do an explicit for loop. Whichever way it's going to work out, you're going to have value columns that you could be using to change the name of your columns. But I have to create a column list because my column list that I want to change the name of the columns have to match their numbers. The number of items this column list has to match the number of the columns that the data frame have. So I want to change the first four. Let's look at them by those names. So these are the first four. And then after that, I want it to be W1 all the way to W76. So I, change the name of what I want. And then I add that value column that I just created. And then I change the columns from the data frame to those ones. And now I was able to, now I have a workable or manageable name for my value columns. So once you have this, now you can use your value columns to do the melting. So the melting part is done, but then if I want to create that same date that correspond to these dates, I have to now do the same thing with the applying that function to change the integer, but there is a little bit of challenge over there. So stop this video and try to do the same thing, but for this bigger melted data frame, and see how that goes for you. So basically the challenge is the fact that after week 9, now week 10 is going to have 2 characters representing a number, and you want to be able to capture that. So to do that, you have to introduce an inline if statement in your lambda function. So if the length is equal to 2, you want only just the second character. But if not, that's not the case, you want from the second character all the way to the end. And that is going to just work for you fine. And once you run this, now you are able to have done that melting, and the date is already also there, and you will be able to also keep the only columns that you're interested in, and you can also look at one of the tracks that the challenge has requested, and can also see all of your data completely melted, and for you to just look at and start using.